Hello, welcome back to Ling 201, Introduction to Linguistics. I'm your instructor, Brett C. Nelson. This is week 6 of the semester, and today we'll be talking about phonology, and specifically derivations and phonological rules. The readings for today were from our textbook, Contemporary Linguistic Analysis, Chapter 3, Section 4. Just the one section for this week. Happening later this week on Thursday, the second feedback survey will be due, and this is optional. It will be through D2L. While on Friday, the second quiz will be due, and this is mandatory and due by D2L on Friday by midnight. So I'll start with the land acknowledgement. We're here learning in the area where the Bow and Elbow rivers meet in southern Alberta, a place known in Blackfoot as Mohkinstsis, a name now used to refer to the city of Calgary. This land lies within the territory of Treaty 7, which is signed by this land's stewards, representatives of the Blackfoot Confederacy, the Tsuut'ina First Nation, and the Stoney Nakoda. Additionally, this land is home to speakers of Cree and Ktunaxa, as well as members of Métis Nation of Alberta. I'm a newcomer to this land. I come from Buch, the land of many tongues at the mouth of the Mississippi River. I strive to learn more about the land, its peoples, their languages, and their history every day. At the University of Calgary, I hope to continue a journey of transformation and renewal in our ways of knowing, doing, connecting, and being, all with a spirit of truth and reconciliation for continued shared enjoyment of this beautiful place. So the plan for today, first we'll be describing how phonetic representations are derived from underlying or phonemic representations. Then we'll outline the information necessary to define the phonological rules that make up those derivational processes. And then we'll examine the formal way to write out those phonological rules. After that, we'll work through some phonological derivations and rules, so we're a bit more used to how we formulate all of these ideas into a formulation, the derivation rules. So previously, we determined that there were two levels of representation of sound in spoken languages. There was the phonemic level, which was the abstract meaningful segments. These were made up of the phonemes. This is also called the underlying representation, or UR. And then there's the phonetic level of representation, which is made up of concrete articulated segments. So the things that are actually perceived in the air, heard in the air when it comes to spoken languages, or seen when it comes to sign languages. Well, these are the allophones, which are members of the categories of phonemes. And this, because it occurs at the surface, is also called the surface representation. So how do we go from one to the other in transferring the information from sound into meaning? Well, this is, or vice versa, rather, or either way. Well, we do derivation. This is the processes by which 0 or more, so any number of formal rules apply to change an underlying form into a surface form. So for an example here, we have a diagram of a derivation which applies the rules of aspiration and vowel lengthening to various underlying representations to produce the phonetic or surface representation. So let's pull that apart a bit further. Derivations, they take underlying representation as the input. So at the top of this, we have the input. And so the input's made up of phonemes and their meanings, the phonemes of the word that we're going to derive its surface representation, and the meaning that it imparts on that combination of sounds. And then after that, below that, we have an ordered set of rules that apply to the inputs. So you go from the input at the top, and the first rule you do is below the line there. Then the next line, aspiration, and then vowel lengthening applies after that. So only those rules which are conditioned by the input, or what's available at the input, are those that apply. If it can't apply, then it doesn't apply. So yeah, if it's unconditioned, the rule doesn't apply. And so that means that some rules may not be applicable to some inputs, and that's fine. So they just pass the input on to the output. And if no rules apply to any of the input, to the input at all, if none of the rules are conditioned, then they don't apply. And so the input kind of just passes straight on through, as I said, to the output at the phonetic representation. So the output is that phonetic representation here. So for the word tap, aspiration applies, but vowel lengthening doesn't apply, and then you get the phonetic representation with that aspirated T. With pad, you get both aspiration and vowel lengthening applying, and so you get pad as the output. However, with slap, nothing applies, so the phonetic representation matches almost identically, really identically, to the underlying representation. So these are the allophones that are produced at the surface. So the input is made up of phonemes and their meanings, while the output, the phonetic representation, is made up of the allophones. So here, as I said, the top line is the input, the underlying representation. Then we have the rule names, which we'll break down what these rules are actually doing in a bit. But for this kind of diagram of derivation, we just have the rule names, and that just is kind of a black box that it's not black box, it's a black box for now. We'll make it a white box later, but it is a black box that you just put the inputs into, and it produces these intermediate outputs. And then so the rules that are conditioned do apply, and those that don't apply. So then what we get at the end is at this purple level, the phonetic representation: tap, pad, and slap. So yeah, I thought I mentioned rules there. What are rules? How do we kind of outline them? Or how do we know what actually is going to happen and what their conditioning environment is with just a name? Well, of course, we have more than a name. We have ways to describe what is causing those rules to apply and what those rules actually do. And so that's the formalization of these phonological processes, are what these rules are made up of. And so these rules are at a more individualized level than those derivations. Derivation is makes up all of the rules that can apply to a underlying representation to get the phonetic representation. Rules are just individual that may or may not apply on their own. So more than one rule can apply within a derivation. Often more than one rule does apply at a derivation. And so these rules, because they're at an individual level, they don't directly link the input to the output. They just create intermediate forms. So these intermediate forms may be the input for a later rule to apply onto. And so they take those inputs and form the intermediate form output. So for our diagram, the inputs will be red, the purple will be the process, and the blue would be the output. So A becomes B by way of the purple arrow. And so this is usually based on conditioning environments. So we'll see a bit what that means. But for our diagrams for the conditioning environments of these rules, the underscore, probably two underscores technically, whatever it is, it indicates the position of the input form that would make the purple. So where you would basically insert A between X and Y for purple arrow to apply to produce B. So if we were to just read this, it would just be letters, but we can make this into more sensical language, English language, by saying A becomes B in the environment between X and Y. That's what this rule basically says. X on one side, Y on the other, X to the left technically, and Y to the right. When A is in that position, it will become B. That's what that rule says. So let's have a more concrete example beyond that kind of simplistic schematized. schematicized diagram, we have an actual rule, and one of the rules we looked at on the last slide with the vowel lengthening, we've talked about previously in this course. So with English, vowels lengthen before voiced obstruents inside the same syllable. So that's what that rule would look like. But let's actually break down what's happening here. So for our purposes, within these rules, confusingly enough, the lowercase sigma, that symbol here, refers to a syllable boundary. So it can be on the left or the right. If it's on the left, it means it's the left boundary, or the start of the syllable. If it's on the right, it's the right boundary or the end of the syllable. We can also have a hashtag or a pound sign, and that refers to the word boundary rather than the syllable boundary. So it's the beginning of the word if it's on the left, it's the end of the word if it's on the right. Rules can apply, can have either of those or none of those as their conditioning environments. So that's important to know. So in order to break down this rule, we have to refer to its features, the features that will select the segments that condition it, the segments that are the inputs, and the segments that are the intermediate outputs. So for our purposes, a vowel is shorthand. You could also put just a V symbol, but it is shorthand for the features minus consonantal and plus syllabic, and that becomes plus long. So that would be, you're adding a long feature to the vowel, plus long feature, in the environment before a voiced obstruent. So we would break down voiced obstruent with plus consonantal, because all obstruents are consonantal, minus syllabic, all obstruents are also minus syllabic, minus sonorant, all obstruents are also minus sonorant, and plus voice, that gives us only the voiced obstruents. And then we'd also maintain our syllable boundary to the right. So we put all of those features in a bracket or a brace, and that tells us that it's referring to a single segment that meets all of these criteria features. So we take minus consonantal plus syllabics, we make them long before plus consonantal minus syllabic minus sonorant plus voice segments inside the same syllable when the syllable boundary is to the right. And so what that means is vowels become long before voiced obstruents inside a syllable. So specifically, if we want to draw out a really specific example, or a specific linguistic example, rather, again, we're just building up towards actually applying rules to linguistic data. We have the example for dad. So the phoneme dad, the word dad, that means like father, the name for father, has these as its underlying phonemes. And so we want to turn this into its surface representation, its phonetic representation. So this rule applies to vowels, so we'll just look right at the vowel. So a is the underlying vowel, and it becomes long when it meets this criteria. So let's break down the segment that follows, the coda segment. It is plus consonantal. If we look at our feature matrix in the book and from our previous lectures, the D is plus consonantal minus syllabic minus sonorant plus voice. It also happens to be minus continuant, and its coronal feature is plus anterior, the tongue's moving forward. We still have that, that syllable boundary to the right, and so this would be the description of what's actually happening. But the minimum criteria for this rule is the one above with the plus consonantal minus syllabic minus sonorant plus voice. This is just to show that it does meet all of those criteria plus some more that actually specifies the individual segment that we're talking about. But a becomes long is the key point here. A becomes long before D. So that is one of the rules. There's lots of rules that we could talk about in this course. and we have talked about already, but let's break down another one of those rules. So that is the aspiration of stops in English. So recall what we said last time about aspiration in English is that voiceless stops become aspirated in stressed syllables, at the beginning of stressed syllables. And so that's the way to represent it in our diagram here is a V with an accent mark, an acute accent mark. And it's to be at the beginning, we have put the syllable boundary to the left. So that means we're talking about stressed syllables or stressed vowels, and the onset position before them is the conditioning environment. So in order to break that into features, we have to, in order to apply this rule, we have to look at what features are necessary for this rule to apply. And for voiceless stop, those features are plus consonantal, minus sonorant, minus continuant, minus voice, minus spread glottis. And so that will capture all of the unaspirated voiceless stops in English. And the output of this rule is to make them aspirated. So the feature that does that is plus spread glottis. So minus spread glottis is changing to plus spread glottis is basically what this rule is doing in terms of the features it's changing in order to get to the next level of the derivation. And then, so to break down this conditioning environment, syllable boundary to the left of the input is good enough, but we need to break down this vowel into its features. So it can be described as minus consonantal, plus syllabic, plus stress, and that is it. Those are all, minus consonantal plus syllabic gives you all of the vowels, and plus stress gives you the stressed vowels. So stress is a feature for our purposes here. And so that will give us the rule for aspiration of stops in English. So voiceless stops gain plus spread glottis before in the same syllable of a minus consonantal plus syllabic plus stressed segment, which is a stressed vowel. So voiceless stops become aspirated in the same syllable before stressed vowels. Key here is that this syllable boundary means there's an actual syllable boundary here. So if there were an intermediate S here, like a segment S, then this rule wouldn't apply because it's not at the pure beginning of the syllable. There's an S there, so this rule is not that would not meet the conditioning environment for this rule. And so this rule would not apply when there's an S followed by a stop followed by a stressed vowel. We need this to be exactly at the left edge of the syllable. So that's a general rule for aspiration of stops in English. So we now have enough information to perform the derivations from the derivation of the three inputs that we had earlier. We defined those rules of aspiration and vowel lengthening. So we just throw them into our little gray box now. Now we can apply those rules to get the derivation that we want. So the input of unaspirated T, ash, P gets aspiration and no vowel lengthening to get tap. Then unaspirated P, ash, D gets aspiration on the P and vowel lengthening on the A to get pad. And then for slap, S, L, ash, P, nothing applies. And so the phonetic representation matches the underlying representation for these derivation. So note, however, that these rules are really quite distinct in what they're looking at. You're talking about the initial consonant, the initial stop for aspiration, and you're looking at the vowel of a syllable for vowel lengthening. And those are really two kind of mutually exclusive sets. So they don't really ever affect each other. So because they don't affect each other, the order of these rules doesn't seem to matter. But does that mean they always are that way? No. Sometimes order does matter, and because if you have an intermediate output that conditions the environment for a later rule, then you would need that, and you want that rule to apply, then you would need the one that outputs the conditioning environment to be before or above that later rule. So yeah, as I say it again here, sometimes rule 1, which is called a rule, can produce the conditioning environment for another rule, rule 2. If rule 1 applies before rule 2, then rule 2 is conditioned and can therefore apply. But if we make rule 1 apply after rule 2, then rule 2 is not conditioned and can't apply. So we need to order our rules based on what we're seeing at the surface. If we see that rule 2 is applying, then it's probably true that rule 1 is applying before rule 2. But if we know rule 2 exists and it's not applying to the derivations we're looking at, then we have to make it so rule 1 applies after rule 2. So an example would be, in this case, with schwa deletion. So there is a rule in English that deletes schwas, and particularly unstressed syllables. So schwas can delete in light syllables before stressed syllables. So the rule written out here would be schwa becomes nothing. That's the null symbol. Becomes nothing in the environment after a consonant before a syllable boundary, and then a consonant followed by a consonant and continues. So ... means things happen. All that matters is that we have a syllable boundary and there's more syllables afterwards, and that happens. And so the plus stress applies to that vowel. So the vowel is plus stressed, or whatever is the nucleus of that syllable is plus stressed. And so that is the conditioning environment for schwa deletion. And another rule is liquid devoicing. So in English, liquids become voiceless after voiceless stops in onset. So plus consonantal, plus sonorant, minus nasal, minus syllabic will get you liquids in English, and they will become minus voiceless. They'll lose their plus voice feature. In the environment of a syllable boundary followed by a consonant that is minus voiced and minus distributed. So plus consonantal, minus continuant, minus distributed release, minus voice. And then if that liquid is there to the right of that, then this rule applies and you get a voiceless liquid. So if we look at an example like this one, the word is political, which means is the adjectival form of politics, so something to do with politics. We get stress assigned to the underlying form, and then the rules we're talking about here, rule 1 is schwa deletion, rule 2 is liquid devoicing. Schwa deletes, and then the liquid devoices because we have a syllable beginning with a voiceless obstruent, voiceless stop. So voiceless stop before a liquid will cause that liquid to devoice. And so we get political. That L is voiceless, even though at the underlying representation, it is not following a stop. But at some point in between the underlying and surface and the phonetic representation, that first vowel deleted. So now that stop and that liquid were next to each other, so liquid devoicing could apply. However, if we ordered these rules the reverse, so that liquids devoiced before schwa is deleted, there's the conditioning environment for liquid devoicing is not met if the schwa hasn't been deleted yet. So we only get schwa deletion and we get political. And so what we're left with at the surface is a voiced liquid, which is not what we see at the surface. Most speakers of English will have a voiceless liquid there if they're deleting their schwas. So we know that schwa deletion occurs before liquid devoicing. And this tells us that our rule ordering is very important to how we draw up these derivations. So be sure to order your rules correctly when they do indeed impact each other. So a little intermission here. A fun extra note to the types of relationships between rules. We have a fun terminology for this, which I learned a bit late in my linguistic training. But so I think it's appropriate that you learn about them. I won't require that you know these, but I thought you'd be interested to know that's what we call them. So the first of these is a feeding relationship. So when rule 1 creates rule 2's conditioning environment, like we saw with a schwa deletion causing a voiceless stop to precede a liquid, then rule 1 is feeding rule 2. So schwa deletion feeds rule 2 because it's in a feeding relationship with rule 2. The opposite of this, when a rule destroys rule 2's conditioning environment, is a bleeding relationship. So rule 1 bleeds or blocks rule 2. So it's called a bleeding relationship, which is kind of weird when I first learned about it. But if you think about it, it is a kind of a block feed. Block feed is blah plus ed is bleed. And so it blocks the feeding relationship of a feeding relationship. And so it becomes a bleeding relationship between rule 1 and rule 2. So when rule 1 is actively destroying what would otherwise allow rule 2 to apply, then it's blocking rule 2, it's bleeding rule 2, it's in a bleeding relationship with rule 2. So that was a bit of fun for our intermission today. Feeding and bleeding with no blood involved. Okay, so moving on. Let's try to put this into practice and formulating a rule. So an observation, so this is how most phonological analyses start, is we make an observation. So I'll give you that observation here. Most dialects of English do not permit nasals to follow stops and onsets. So when a word or a name with this sequence is borrowed into these dialects, a schwa is inserted between the consonants. So for an example, it would be like a Russian name, Dmitry. Dmitry. It is how an English, a native speaker of English might pronounce that name, usually Dmitry, not Dmitry. With something that was perhaps an English name 1,000 or so years ago, Knut. Knut is more of a just a Scandinavian name now, but it was at once an English name. In Scandinavian languages, they pronounce it Knut, Knut. But when an English speaker would pronounce it, they might say Knut, Knut. They'll add the schwa before that nasal to break up that cluster of a stop plus a nasal, because they don't allow nasals to follow stops and onsets in their phonotactics. So what is this a case of? Well, if you're paying attention, you know that this is schwa epenthesis rather than schwa deletion. Epenthesis or insertion is the opposite of deletion. You're adding a schwa in order to make a sequence easier to pronounce. In this case, you're adding it between that stop and that nasal. So what would our rule look like for this? Well, it would look like this. If you could think about the features for a bit, the conditioning environment is at the beginning of a syllable between when you have a stop followed by a nasal, and nothing in between them, English speakers would want to put something, the schwa, in between them. So the stop, to draw out the features for that, would be plus consonantal, minus sonorant, minus continuant, minus distributed release. And then the nasal features, the features for the nasal would be plus consonantal, plus sonorant, minus continuant, plus nasal. And so I have the features incorrect here. I'll fix that when I post the slides. But that will give you all of the nasal consonants, and the first bracket will give you all the stop consonants. And so the conditioning environment in words would be nothing becomes schwa at the left edge of syllables where a stop is preceding a nasal with nothing in between. So this represents the input, and the input happens to be nothing. So when we just say nothing's there, so a stop followed by a nasal at the beginning of a syllable will be the conditioning environment for the schwa insertion rule. And so that's how we would formulate the rule for that schwa insertion based on these two data points. We see a stop followed by a nasal. This one's a voice stop, whereas this is a voiceless stop. Canute, there's also get aspiration, but I'm not focusing on that, so I didn't transcribe it. But Canute and Dimitri become Dimitri and Canute based on this rule. So that's one hugely important point for rules. Another use for rule is to describe our allophonic processes. So we talked about the allophony between voiceless stops and aspirated stops. That is one of the ways we can use rules to just illustrate that allophonic description we had previously with our allophonic trees, and put them into practice with these rules that we use to get from an underlying representation of a whole word into the phonetic representation of that word with its allophones. So to break away from that stops, we'll talk about the lateral liquid in English for another allophonic rule that we haven't actually discussed at any point this semester. So L, the phoneme L in English, usually has two main allophones in North American Englishes. The velarized or dark variant, L, so it's L, it's the L symbol with a kind of tilde across the middle of it. L is the velarized or dark L, occurs after vowels, while the light variant occurs everywhere else. Otherwise, in other words, before vowels or after consonants. And so how would we draw the rule for that? Well, first, let's consider the allophone tree so we can really think about the conditioning environment. So what is the allophone tree for these allophones of the phoneme L? Well, we have the top here is the allophone L, the phoneme L. And so after vowels, it becomes L. And then everywhere else, it becomes light L, which is the normal L symbol. And usually we put the elsewhere, the most common condition, even though it doesn't really make sense here, because you think after vowels it would be on the right, but that doesn't mean anything for this tree. We're just talking, it's really an arbitrary selection. And usually the arbitrary selection is that the elsewhere condition, as we'll call it, the one where everything else can't apply, so it's just kind of like you just throw everything into this as like a wastebasket. And the elsewhere condition is on the right of our allophone trees. And so after vowels, it's the dark L. Everywhere else, it's the light L. So what rule can we write for this distribution? Well, first we'll need to add a feature to the phone. We'll need to add features to a phone that's in the feature chart, or the feature matrix. So the features for L are what we think about it: plus consonantal, minus plus sonorant, plus continuant, plus lateral. That'll get you L, I'm pretty sure. And then you'll have your coronal features, of course, your coronal feature plus anterior, because the tongue is moving up and forward to the front of the mouth. So that will get you the features for L, but we have to be adding velarization, which means you're aiming towards the velum instead. So that's going to be the insertion of dorsal features, and those dorsal features being high and back to get you the place of articulation of velar for these consonants. And the conditioning environment is after vowels. So a vowel would be minus consonantal plus syllabic, and then we put our location symbol, the underscores, after it. So that means L's become dorsal, high, and back, which means velarized after minus consonantal plus syllabic, after vowels, basically. And so that would be the rule for this process, which would be the velarization of L after vowels. And when L is not after a vowel, this rule doesn't apply. So the L just stays the same throughout the whole derivation from the phoneme L to the surface form of that light L with the same symbol, but in phonetic brackets. You can also write out that elsewhere condition in a rule. So you can just put it stays the same, or the same segment within the same symbol within phonetic brackets in the condition of dash dash dash. And dash 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 is another shorthand we'll use for our rules, which means elsewhere. So it basically means anywhere else that we haven't already talked about in this rule, this is what applies. It's the elsewhere condition. It basically means what happens when the rule doesn't apply technically. So yeah, those 3 dashes is another shorthand you'll have to know for drawing up the rules, which means the elsewhere condition, which you usually draw. Again, that's why on the allophone tree it's to the right, because it's usually at the end or the bottom of our rule specification with all of our features. It's almost necessary, that is, because you're assuming that if one of the conditioning environments above did happen, it needs to be above for that to happen. If it doesn't, then you get down to the level where nothing happens in this elsewhere condition. And elsewhere conditions don't have to be do nothing. They could also be other processes which form an allophone from the phoneme. So we'll spend, I think, the rest of the day practicing with allophony. So I have a couple more slides here with more allophones of phonemes for us to draw up rules with reference to our feature matrices. So this is really pulling together all 3 weeks of our phonology lessons into one really useful application with these phonological rules. So this would be like something that might appear on an assignment. It asks you to examine the following data from standard German, which show that ch and ch, so that's the velar fricative and the palatal fricative, are allophones of the phoneme ch, which is the velar fricative. Again, ch and ch. So you might, if you don't speak German, you might not be able to hear those differences. And even if you do speak German, you might not be able to hear those differences because this is an allophone. They're allophones of the same phoneme. What's important here is that they're allophones of the same phoneme. They might not appear in your feature matrices, but we do know how to describe velars and palatals, and we know how to describe fricatives. So if we put those together, we can form the features for those 2 segments. So I'll just read through the examples here. You have acht, meaning 8, echt, meaning real, ich, meaning I, like the pronoun I, Buch, meaning book, Loch, meaning hole, hoch, meaning high, spreche, meaning she would speak, lächeln, to smile, Flucht, flight, riechen, to smell, lachen, to laugh, and vechten, to fence. So once you've examined those data from Standard German, you're asked to do these as well. So draw the allophone tree for the phoneme X. And then write a rule for the allophone tree you drew it in step A. So yeah, as I said, you can form these with features that we know for how to form velars and how to form palatals, but I won't ask you this because they aren't actually in that table. So we'll just write the IPA symbols that will turn X into X, or the C seria, which is the velar fricative and palatal fricative, respectively. But first you have to draw the allophone tree for the phoneme ch. And so that you'll have to examine where ch and ch appear within the data. So you'll have to look either to the left or to the right, sometimes both, to determine after which segments, or I'm giving it away, or before which segments the ch appears, and in which environments the ch appears. All right, so let's come back together. And so for step A, we have to draw the allophone tree for phoneme X. So, I mean, we're given that these are allophones of the same phoneme. All we have to find is a conditioning environment for one or the other. And so to look for the conditioning environments, you just look to what's to the left and to the right of each of the allophones that we're looking at. So with number 1, we have acht, which is the velar fricative allophone, and that's has an a to the left and a t stop to the right. But in number 2, echt, we have the palatal fricative with an e to the left and the stop to the right. So if we keep the stop to the right constant, we still get a difference. So it doesn't seem like what's occurring on the right is what's changing what's happening with the fricative. We have to focus what's happening on the left. So we have the tense low vowel, acht, and the mid-front lax vowel with echt. So any of those features can cause this change, it appears. So let's move on in order to narrow it down among those features. So next in 3 we have ich, which is the high front tense vowel. But we get the palatal fricative with this one. So if we see what's in common between echt and ich, between those vowels, it's looking a lot like it is the front feature which is causing, or the frontness of those vowels, which is causing the velar fricative to become this palatal fricative. But we need a bit more evidence just to be entirely sure of that. We already know that these are allophones of the same phoneme, so it's not just a minimal pair that'll work for our purposes. We need to be quite sure of the actual conditioning environment in order to draw the allophone tree as specifically as we can, and then to draw the rule for that allophone tree. So the next 3 examples we have are Buch, Loch, and Hoch. So here we have a bunch of back and round vowels, plus a tense and a vowel and a long vowel, a long tense vowel for Buch and Hoch, but then we have the short lax vowel for Loch. So none of these features are causing the change into the palatal fricative, which is a good sign for our hypothesis that this is because of the frontness of the e and the e. So next we have spreche, which we have another front vowel. This time it's the mid-front tense vowel, and it's long as well, which precedes the palatal fricative that we're looking at. So vowel length doesn't seem to matter. Tenseness doesn't seem to matter. It really seems like it's frontness that's what's causing the change from the velar fricative into the palatal fricative. So then we have lächeln, to smile. So another one of those lax, mid-lax vowel, mid-front lax vowels. And then Flucht, a high back round lax vowel. So the lax variant of U. So yeah, that doesn't have any front. So yeah, it makes sense. So I think that's good enough. Riechen, yeah, that's a high front long vowel this time. Then lachen, and then fechten. So yeah, I think we have enough data to really be sure that the conditioning environment for the palatal fricative is a preceding front vowel. And so that's what we would talk about in our allophone tree. So the allophone tree for this distribution would be the velar fricative phoneme ch becomes the palatal fricative allophone ch after front vowels, and stays a velar fricative ch everywhere else. And so to draw or to write up the formal rule for this, which I already said no features were necessary. We'll talk about the features in a bit just to clarify things. The rule would be relatively simple. We have the velar fricative ch becoming the palatal fricative ch in the environment following a front vowel, where everywhere else, the 3 dashes, it becomes a velar fricative. So that would be good enough shorthand to capture what we're talking about. V is shorthand for
minus consonantal plus syllabic, and front is shorthand for plus front. And so if we were to draw out all of those as features, which we could, but again, I didn't ask you to because this isn't English, but and these sounds don't typically exist in English. But if you are interested in how these would be constructed based on features, we could totally do it with the features that we have in English. And so for the velar fricative, first we need to get the manner features which capture fricative, so that would be plus consonantal minus sonorant plus continuant. Then we need it to be voiceless because this is a voiceless fricative, so the feature that gives us that is minus voice. And then you need the place features. So the place features for a dorsal consonant would be plus high and plus back. The dorsal velar fricative would be plus high and plus back. And the change is you're replacing those dorsal features with coronal features. And because palatal, we have some palatal sounds in English, just not the non-strident fricative. And so all you have to do is change those dorsal features for the palatal features, which happen to be coronal features of minus anterior and minus strident. So the difference between sh and ch is one of stridency. The sh is a strident palatal fricative, whereas ch is a non-strident palatal fricative. But the difference between a ch and a ch is between the dorsal features of high and back for the velar ch and the coronal features of minus anterior, minus strident for the palatal ch. And to draw, for completion's sake, to draw out the features for that front vowel. So as I said, V is short for minus consonantal plus syllabic, and the vowel feature front is in the dorsum, so it's dorsal plus front. And then so that replaces all of those segmental representations with feature representations, and then you could use the dashes as you did. So in the environment after this minus consonantal plus syllabic plus front vowel would give you the conditioning environment for the palatal fricative, whereas everywhere else, the elsewhere condition will give you the velar fricative, and all of the features from the input stay the same. So that is basically as complex as a phonology problem as you might get in this course. And so, because it really pulls together all three lectures, we talked about the phonemes and the allophone distributions within the phoneme. We talked about the featural representations of those segments, and then we talked about how to put all of that together with the rule. And so this is really kind of a holistic look at phonology. There will be some other parts of phonology which will be assessed separately, but this is a really core part of, or the whole part of phonology for our sake, for our purposes. So look forward to one or two of these on the assignment to draw allophone trees and for allophonic distributions for allophonic distributions like this, which are in complementary distribution, you would have to draw out the rule which accounts for that complementary distribution. So yeah, one or two of these, and we'll be practicing in the coming days and weeks with similar phonology problem sets like this. But that does it for today's lecture. So I'll leave you with the announcements for this week. On Thursday, feedback 2 will be due. It's a survey through D2L. This is optional if you have time and you've already done the quiz, which is due the next day. Please fill out the feedback so we can improve the course and your learning. If not, just focus on the second quiz for this chapter. The quiz for this chapter, quiz 2, which is due on Friday at 11:59 p.m. Other than that, we'll be done phonology, and for next lecture, we will be moving on to morphology. We're building bigger and bigger words beyond just these kind of simple 1 and 2 syllable words we've been talking about here. We'll be putting words together with various parts of pieces of words in morphology. So the readings for that will be from Contemporary Linguistic Analysis, Chapter 4. The first half of that would be sections 0 through 3. So thank you for watching. Thank you for participating in solving some phonology with me. It's been a joy, and yeah, I'm just very appreciative for watching. So don't forget to like, comment, and subscribe.